Have you ever looked at a third grader's math homework and just thought, this looks absolutely nothing like how I learned it? Yeah, you're not alone. Let's get into this, because what's happening in third grade math isn't just about learning new topics, it's a complete rewiring of how a child's brain is built to understand numbers.
Right? It's the question so many of us are asking. You see these arrays and number bonds and all these strange diagrams for what seems like simple multiplication, and you just wonder, what happened to the good old flashcards? Well, it turns out there's a fascinating and really important reason for all of it.
Here's the core idea, the whole ball game. Third grade is this watershed moment where a child's thinking has to shift. We're not just talking about learning new facts. We're talking about a deep cognitive leap that literally sets the stage for all future math, from algebra all the way to calculus.
So, what is this great leap? Well, it's all about moving from what's called additive thinking, counting things one by one, like 1 + 1 + 1, to multiplicative thinking. This is that magic moment when a child learns to see the world not just as a bunch of single items, but as a system of equal-sized groups.
And this right here is the key. Multiplicative reasoning is about seeing 5 groups of 7, not just counting all the way up to 35. It's the mental architecture that holds up everything that comes next. Understanding fractions, calculating the area of a room, you name it. Without this fundamental shift, higher-level math becomes almost impossible. So to build this new way of thinking, the curriculum pretty much everywhere is built on these 4 big pillars. You've got multiplication and division, which is the main event. Then there's the first real dive into fractions. You connect all that to measurement and data. And you even use geometry and the properties of shapes. The thing is, they all work together to support that one big cognitive leap. Okay, but here's where it gets kind of wild. While those pillars are pretty similar everywhere, the actual expectations can be wildly different from one state to another. Just look at this. For place value, a kid under Common Core standards is working with numbers up to 1,000. But in Texas, they're expected to go up to 100,000. And it's not just that. Texas also folds in financial literacy, while Florida puts a really strong emphasis on algebraic reasoning right from the start. These are not small differences. They completely shape what a kid's third grade year looks like.
So why these huge variations? Well, it's rooted in this much deeper, decades-long debate in American education, a conflict that people often call the math wars. And listen, this isn't a fight about whether 3 times 4 equals 12. It's a fundamental clash over how we believe kids learn math best.
So on one side, you have the push for what's called conceptual understanding. This is all about the why. The idea here is to let students explore, to struggle a little bit in a productive way, and to really build meaning for themselves before they're just handed a formula. Then on the other side, you have procedural fluency. This is the how. This philosophy emphasizes mastering the standard steps, the algorithm, through really clear, direct instruction from the teacher. For years, everybody's been arguing about which one is more important.
But here's the twist in the whole story. The research is actually crystal clear. It's a false choice. You absolutely need both. As the National Council of Teachers of Mathematics puts it, understanding the why should come just before and at the same time as learning the how. See, the real question isn't which one to teach, but in what order you teach them. Because think about it. Once a kid has memorized a procedure, a shortcut, without understanding it, they have basically zero motivation to go back and figure out why it actually works.
So if it's not a war, then what's the path forward? Well, decades of research have pointed to a really clear, powerful sequence that builds both of these things, the understanding and the fluency. It's the perfect way to bridge that gap between the two philosophies. It's called the Concrete Representational Abstract Sequence, or CRA for short. And it is as simple as it is profound. You start with something concrete, real physical objects that students can actually touch and move around, like blocks or tiles. Then you move to the representational phase, where they draw pictures or models of what they were just doing. And only after they have that solid foundation do you connect it all to the abstract, the numbers and symbols that we usually think of as math. So what does this CRA sequence actually look like for those tough third grade topics? This slide gives some awesome examples. For multiplication, you might start by physically building groups with counters. For fractions, use tangible fraction bars that kids can hold and compare. And for area, my favorite, you can literally cover a shape with cheese crackers to get a feel for what square units actually means before you ever see a formula. This is how you build a mathematical brain from the ground up.
And look, getting this right has never been more critical than it is right now. The teaching methods we're talking about aren't just some nice theory. They are absolutely central to tackling the biggest educational challenge of our lifetime: recovering from the academic impacts of the pandemic.
The data is just staggering. National test scores from 2022 showed that math achievement for 9-year-olds completely plummeted. It wiped out 2 decades of slow, steady gains, dropping to levels we haven't seen in 20 years. The pandemic didn't just slow down learning, it sent it backwards.
And the recovery has been painfully slow. Researchers who are tracking student progress estimate that at the pace we're on right now, it will take more than 7 years just to get back to the math achievement levels of 2019. Think about that. The kids who were in 3rd grade during the pandemic will probably be out of high school before we see a full national recovery.
And this slide really highlights how unique the problem is. It's comparing the recovery in math versus reading. And you can see that while math is making slow but steady gains, reading recovery has really stalled or even declined. Now, one big theory for this is that schools have poured resources into math recovery, both because the initial drops were so catastrophic and because math skills are so sequential. A gap in 3rd grade math creates a massive domino effect for years to come.
So, faced with this enormous challenge, where do we go from here? The good news is we do not have to guess. The research gives us a clear, evidence-based roadmap for not just recovering, but for building a stronger and more resilient system for the future.
First, we have to resist the temptation to just drill. We've got to prioritize that deep conceptual understanding using the CRA sequence. Second, we need that balanced model. Let kids explore an idea first, and then follow up with explicit instruction to connect their discoveries to efficient methods. Third, we have to scale up the things we know work, especially high-dosage tutoring for the students who are furthest behind. And finally, none of this happens if we don't invest in our teachers through high-quality, ongoing training.
Ultimately, the challenge we're facing isn't a lack of knowledge. We know how to build mathematical brains. We know how to bridge the gap in the so-called math wars. And we know which interventions are the most effective for helping kids catch up. The path forward is clear. The only question that remains is whether we as a system have the collective will to actually follow it.